The annulenes. What are the annulenes? It is a cyclic conjugated hydrocarbon. Cyclic conjugated hydrocarbon is called the annuline. So annuline is 4 annuline. It is annuline 4 because we have 4 carbon. Is it an annuline? Is it not an annuline? Is benzene is an annuline? It is annuline 6. Is this is an annuline, and this is annuline 8. This is anti-aromatic. This is aromatic, but this is actually a non-aromatic. Why it is non-aromatic? Because it get into tub shape. Because of the heavy structure, it get into tub shape like this. So it becomes non-planar. So it is non-planar. So it becomes non-aromatic. We talk about annuline 10. Hydrogen over here. Here it is annuline 10. Annuline 10, what is expected? Expected it is aromatic, but actually it is non-aromatic. Actually it is non-aromatic. Why it is non-aromatic? Because this hydrogen has dihedral repulsion. This hydrogen and hydrogen are repelling each other. So this bond goes upside and this goes downside. So when they both are repelling each other, so they become non-planar, and non-planar means they become non-aromatic. So we have some other compounds like oxygen. This is aromatic. It has 10 pi electron. So there is no repulsion because it becomes planar now. Because oxygen is have taken all the hydrogen repulsion to itself, so it becomes planar. Similarly, if we have NH group over here, it becomes planar. Similarly, if we have CH2 group over here, it becomes planar. Aromatic. Now we have two CH3 groups. It is a non-planar. Now we have benzene. It is aromatic. Now we have this compound. So it is actually out of non-planar. So it is aromatic, non-aromatic. Non-planar means non-aromatic. Now we have some reactions that involve aromaticity. Reactions involving aromaticity. How the reactions involve the aromaticity? First, we're going to talk about the hydrogenation. Hydrogenation involves aromaticity. C double bond C H H. So it has H2 and nickel. So it is CH and CH. So hydrogen gets absorbed over here in presence of nickel. So that becomes hydrogenation. Now what happens when we have hydrogen in one equivalent and nickel? So how it will react? So we know that the product should be a maximum stable. Product has to be maximum stable. So when we remove this double bond, so this aromatic and this anti-aromatic ring becomes like this. So it is the most aromatic. But when we break this So one product should look like this. So it is anti-aromatic. This is non-aromatic. So whether we prefer aromatic or non-aromatic, we prefer aromatic. So this is the our answer. So in answer we have to form the product like that. Then it is the maximum stable. So we have to remove the maximum anti-aromatic system. So if we hydrogenate this H2 one equivalent in presence of nickel. So it will form this compound, right? Like thirdly, we have this 1, 2, 3, 4, 5, 6. Now when we have here H2 3 equivalent and nickel. So H2 3 equivalent and nickel we have over here. So what will happen in that case? All these three bonds will, if we remove all these three bonds, we have remained 3 aromatic system. But when we remove anything apart that, then the aromatic ring will remain there. Like if we remove these 3 hydrogen, these 3 the double bond, so we have still 3 aromatic system. We still have 3 aromatic system. 3 aromatic system we have over here. So it has maximum aromatic ring, and here we have minimum anti-aromatic ring. Maximum aromatic ring and minimum anti-aromatic ring. We have other questions. If we have H2 one equivalent in presence of nickel, so we will remove the least stable double bond. So here it is the among A and B, which is the least stable. B is least stable because A is still in conjugation with the benzene ring, but there is no conjugation in the B double bond. So the answer will be like this. Next question. We have H2 one equivalent and nickel. So 1, 2, 3, 1, 2, 3, and here we have double bond. Or betterly, if we draw, we don't have to draw the resonating structure of this. We have this structure. So here we have 2 anti-aromatic and 2 aromatic. So if we remove this double bond, we will having 2 aromatic system. We will be having 2 aromatic system. So 2 aromatic ring. So this will the product. Next, if we have I think you must have understand what double bond we have to remove, due to which we have the maximum number of the anti-aromatic system. We have to remove that double bond. If we remove H2, we have one equivalent and nickel. So which will remove? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait a second. We have 1, 2, 3, 4, 5, 6 double bond. Now, what we remove? Due to 6 double bond, it is become anti-aromatic. So it's better to convert from anti-aromatic to non-aromatic by removing this middle one double bond. So if we remove this middle one double bond, so it is become now non-aromatic because it is not a ring, right? Now it is not a ring. It is not a multiple phenyl ring. So it is now non-aromatic. It is anti-aromatic over here also. Now second type of reaction is the sodium metal, Na metal. So sodium metal we have 4 pi electron. 2 sodium will lose 2 electron. So it will become negative over here, Na plus over here, and Na plus over here. It will become spontaneous reaction. The reaction will be spontaneous, right? But when we, because it is anti-aromatic to aromatic, it is very spontaneous reaction. Even anti-aromatic to non-aromatic, we can say it is spontaneous. But aromatic to non and or anti, it is non-spontaneous. So this reaction will not occur because it is already stable. It is aromatic. So actually, sodium will lose Na plus electron. So electron will opt by the benzene ring according to its requirement. Like we have this and we have 2Fe plus 3. So Fe plus 3 has a tendency to absorb the electron. So we have positive and negative. This negative will lose 2 electron. It becomes 2Fe plus 2 and it will become a positive charge. It will become an aromatic system. It becomes an aromatic system. Now we have Na over here. So Na will lose 2 electron. 2Na will lose 2 electron. So it will become 2 negative charge over here. So both rings are becoming the aromatic ring. So it is the aromatic system. It is the multiple phenyl ring. The fused ring, multiple ring are attached and we have to check the periphery. Now if we react with this hydrogen, sodium, we know sodium react with an acidic hydrogen, it releases H plus and this becomes salt. So this hydrogen is acidic because when it loses the hydrogen, this will become aromatic. So Na plus and it will lose the hydrogen. Now we have Lewis acid base reaction. Lewis acid base reaction. Lewis acid base reaction RCl when we react with AlCl3. It will become RCl, Al, Cl and Cl. It will have delta positive and it will have delta negative. And form R plus plus AlCl4 negative. R plus and AlCl4 negative. So first we have Cl. When we react with SbCl5, it will become it will lose the chlorine towards the SbCl plus Cl5 and it will form. It will lose the chlorine and it will form SbCl6 minus. In second case, chlorine it will react with AgNO3. AgNO3 with halogen form AgNO3 with halogen form. Here we have a positive charge and it will become with NO3 minus and it will become AgCl precipitation. Right. When we have next Cl, when it reacts with AgNO3, it will become AgCl plus NO3 minus. It will become precipitation of AgCl because it is become from non-aromatic to aromatic. Non-aromatic to aromatic. So it will easily lose. It will easily lose the chloride ion. It will easily non-aromatic to become aromatic. So it is easily losing. So now there is a question which will form precipitate with AgNO3. First, we have Br. Second, we have this Br. And third, this Br, which will form precipitate with AgNO3. First, second, third. We know the third one because when it will give react with Ag plus, it is form aromatic. Remaining will not form an aromatic system. Fourth type of reaction is actually combination reaction. Fourth type of reaction. It will form a double bond like this. So yes, they will combine because it is from anti-aromatic to non-aromatic. Yes, they will combine like this. The bond will break, each electron will separate, and they will combine like this. In next reaction, we have this type of system. Yes, if we have two moles of this, they will combine again like this. They will combine like this. So next is spontaneous reaction. We have to check spontaneity of reaction. We have to check the spontaneity of reaction. Now, how do we check the spontaneity of the reaction? We have to just see whether the reaction will form a aromatic product or not, or from non anti-aromatic to non-aromatic. So let's, if we have this type of question, bromine, whether it will react with AgNO3. No, it won't react because it will form a non-aromatic. When bromine will go here, it will form a non-aromatic compound. So no, it will not react. Second, Br, whether it will react with AgNO3. So it will, yes, it will react with AgNO3. Third, whether react with sodium metal. Yes, it will react with sodium metal because one of the ring is non-aromatic. It will form, and it will, one of the ring is anti-aromatic, and it will form both the ring as aromatic system or overall the system to be aromatic. Now there is one more question, like fourth, chlorine when react with AgNO3. Yes, it will form AgCl positive plus NO3 minus plus AgCl. Yes, it will form the precipitate because it will form an aromatic ring. Question, we have to write the rate of reaction which will react very fast. Br, AgNO3, Br, AgNO3, Br, AgNO3. So it will become an aromatic product, it will anti-aromatic, and it will become non-aromatic. So the rate will be very fast in first, then third, then second.